Okay, so let's talk about the order of volatility. So what does that mean? Well, as we know, computer evidence is stored in a number of locations. It can be stored on a magnetic disk, it can be stored in flash, it can be stored in RAM, etc., etc. So some locations are very temporary. Okay, RAM, or random access memory, is one of those. So everything that your computer does when it interacts, it doesn't actually, the CPU or the brains of your computer or your smartphone or your game console or whatever it is, all of those things have a CPU of some sort. That CPU cannot actually communicate directly with the data on disk or the data on a flash drive or what have you. It actually has to pull that data into RAM. Okay, that's the intermediary, the staging area, or whatever you want to call it. That is the place where information actually interacts with, or the place I should say the CPU talks to when it needs to, do some type of process. So the information in RAM is fresh. It goes in and out very quickly. Okay, there's only a finite amount of RAM, and things that come into RAM, if it's already full, then it will cache out or swap out or page out, depending upon the operating system that you're using. It'll take that data out of RAM and place it onto disk. Well, as you might guess, that RAM can go away very quickly if the computer is turned off or if it loses power. So that's one thing we have to be aware of. All right, some locations are longer term. So even after deletion, that information or that data remains. Okay, magnetic hard disks are a good example of that. As you may have heard before, or you may know firsthand, if you delete a file from a disk, in other words, you just simply highlight it and click delete, that file is not actually deleted. What it is it takes off the master file table, right? Or again, or it depends upon the operating system how that actually functions, but there's some table of contents, quote unquote, that has all the pointers to where those files are located. So when you delete a file, you simply remove that marker. All right, so and you ultimately say, hey, this file is now capable or able to be overwritten. Okay, this location of data is no longer needed. So it takes the pointer away, so it makes it look like the file is no longer there, but the data itself remains until it's overwritten. Okay, and this pertains to hard disks. Flash drives are a little bit different. We'll talk about that in a moment. But for magnetic hard disks, if you delete something, it doesn't go away. Some locations, as I just mentioned, are long-term. But once deleted, they quickly become irretrievable. Okay, and this specifically refers to SSD or flash drives. All right, so basically with magnetic disks, we can place our ones and zeros or our bits on the disk. And if we erase that or we mark it for deletion, those bits remain. With an SSD, you can't overwrite information in an SSD. If I have information there and I now mark that file for deletion, I can't simply just overwrite it because it can only have two states, on or off. It's a flash drive, all right? So I need to actually erase that and set it back to zeros so that it can then be overwritten, okay? So when that happens, I'll mark the file for deletion, and then very quickly behind the scenes, there's a trim process or a garbage cleanup function that takes place, and it will then clear that data out. So once you delete it off an SSD, sometimes within minutes, sometimes within half an hour or an hour, depending upon the type of flash drive and what functionality it has, that data will be basically deleted and it's irretrievable. Okay, so from a forensics perspective, where that data is stored obviously has some type of bearing on how quickly you need to access it and the order in which you should access it. So again, with the order of volatility, data should be gathered based on the life expectancy, quote unquote, of that data. All right, so the CPU, cache, and register content, okay, the things that are closest to the CPU that need to be there, or need to have power there, I should say, for it to exist and continue to exist, that is the top of the priority list. We want to try to capture that information first, because that information most often than not, or more often than not, will have the most probative value. Okay, but it's also the easiest to disappear. If we turn the computer off, that information is gone. Next, the routing tables, ARP cache, process table, kernel statistics, again, all things that are very volatile. Memory, RAM, all of these things, temporary file space, swap space, data on hard disk, remotely logged data, data contained on archival media, etc., etc. So as you can see, it goes from the things that are very ephemeral, or if we power that computer off, it goes away. So those things need to be captured, if at all possible, first. And there are tools we can hook up to a computer. Okay, we can attach either locally or remotely that allow us to basically capture that data without actually contaminating it. All right, and then we can do the same thing with routing table, ARP cache, memory, etc., etc. The remaining things, temporary file systems, the swap space, and so forth, we can capture that because it's actually written to disk. and the data on the hard disk. So we can do that in a slightly more methodical, deterministic fashion with the data in that volatile space, memory and RAM and so forth. That's a little more difficult to capture, but it also provides a lot of times the most value because it shows us exactly what was happening just within a few moments ago.